You can show your friends how to lift an ice cube out of a glass of water with nothing but a piece of string. Would you like to know how? Then keep watching.
Hello, young neighbors. Welcome to Junior Science. Today we're going to do some exciting experiments with ice. Now, we all know that water can take three forms. It can be a solid, a liquid, or a gas. The difference between the three forms is heat. If you add heat to ice, the ice melts, becomes water. If you take away heat from water, the water freezes, becomes ice. And that's exactly the way ice is made in a refrigerator. In an electric refrigerator, a liquid is pushed into a hollow casing through a narrow pipe. There is more room in the casing than in the pipe, so the liquid has less pressure on it, and it evaporates. In evaporating, it takes heat from the water in the trays, and the water turns into ice. Now, there's a certain way in which water freezes. What is that way? Well, here's an experiment you could do to find out. Pour some water into a test tube. Place a thermometer in the tube, and stand the tube in a glass of cracked ice mixed with salt. You'll see that the temperature of the water in the test tube drops steadily until it reaches 32 degrees Fahrenheit. Then the water in the test tube begins to freeze. You can see that it is only partly frozen by the fact that you can move the thermometer up and down. It takes several minutes for all the water in the test tube to freeze, and while it is freezing, the temperature remains the same. When all the water in the temperature drops again a few degrees. If you are wondering why we put the test tube into ice mixed with salt, here's a stunt that will show you, and that you can show your friends. First, float an ice cube in a glass of water. Then challenge a friend to lift the cube out of the glass with the help of nothing but a short piece of string, and without getting his hand wet. He'll try to figure it out, but he won't be able to. Then you show him. What do? Why, just soak one end of the string in the water and lay the wet string across the top of the ice cube. Then get a shaker of salt and sprinkle some salt along the string. The salt makes the ice near the string melt. But in a few seconds, the melted ice freezes over the string, and you can lift the cube out of the glass. Why does it work? Well, a mixture of salt and ice does not freeze at the same temperature as ice alone does. It freezes at a lower temperature. When you put the salt on the ice, the temperature of the ice cube is not low enough for the salt and ice mixture to stay frozen. So the salted ice melts. In melting, the salted ice robs heat from the ice near it and from the water on the wet string, and they become cold enough to freeze together. Now we can see why we used a mixture of ice and salt to freeze the water in the test tube. It's because a mixture of ice and salt makes water colder than ice alone does. Now let's find out another interesting fact about ice. Take a tray of ice cubes out of your refrigerator and examine one of the cubes. You'll find that it has a bulge near its center. Do you know why? Well, here's an experiment you can do to find out. Get a bottle with flat sides and fill the bottle with water that has been boiled and then cooled again. You boil it to drive most of the air out. Pour in the water until the bottle overflows. Then screw on the cap. Place the bottle in an empty ice tray and put the tray in your refrigerator. Let the bottle stay in the refrigerator overnight. The next morning, open the refrigerator and look at the bottle. You'll find that the water in the bottle has frozen to ice and that the ice has broken the bottle. The reason the ice broke the bottle is that water expands when it freezes. It grows larger. Most materials become smaller when they freeze, but water becomes larger. That's why an ice cube has a bulge at the top, because the water in the tray expands when it freezes and has no place to go but up. The water in the bottle expanded when it froze and broke the bottle. A substance that expands when it freezes can be melted by pressure. And knowing that, you can do a very interesting experiment. You can cut an ice cube right through the middle, and yet the ice cube will remain in one piece. How do you do it? Well, get a thin wire and wrap each end of it around a pencil. Now, place an ice cube on top of a bottle. Then, hold the wire over the cube and bear down hard on the pencils. Pressure causes the ice directly under the wire to melt, and the wire cuts through the ice. But as the ice melts, it steals heat from the ice around it. That ice becomes colder and freezes the water above the wire. So, even though the wire cuts its way completely through the cube remains in one piece. You can skate on ice because the pressure of your skate constantly melts a thin layer of water on which you glide over the ice. You know, in very cold weather, skating is difficult because then the pressure of your skate blade is not enough to melt the ice under it. Now, here's a question for you. If you have an ice cube in a glass of water that is down to 32 degrees Fahrenheit and add more ice cubes, do you make the water colder? Well, here's an experiment you can do that will give you the answer. Put some ice cubes and water into the bottom part of a vacuum coffee maker. Put in a thermometer and stir until the temperature of the water is 32 degrees Fahrenheit. Then place the coffee maker on an electric heater. And turn on the heat. Stir the ice water to distribute the heat evenly, and wait for a surprise. Although you keep adding heat to the water, the reading on the thermometer always stays the same, at 32 degrees Fahrenheit, until all the ice in the coffee maker has melted. Then the temperature goes up. So, if you have an unmelted ice cube in a glass of water whose temperature has already gone down to 32 degrees, adding more ice cubes does not make the water any colder. And now you know a great many facts about ice and have many interesting experiments to try as soon as you get a chance.